Today we're going over why Engineering Explained is believed to be the guardian angel for cars. Do you know how your car works or how to prolong its life? This channel will explain that and more in an easy to understand manner. So, what makes this channel the true guardian angel that it is acclaimed to be? If you want to find out, stick around till the end of the video. From giving simple tips on best practices to reviewing combustion engines, Engineering Explained is a channel that explains difficult car concepts in the simplest ways. The goal of this channel is to help others who are passionate about cars learn how their automobiles work. Complicated car concepts are explained with the aid of simple diagrams, and when they don't seem to be good enough, that part of the car in question is used to explain them. In short, this channel exists for cars and is proven to be the true guardian angel of cars. The man behind the channel is Jason Fenske, a graduate of North Carolina University, Department of Mechanical Engineering, who found his love for cars after playing Project Gotham Racing 3. One game and he was hooked for life. Jason believes that a good way to understand what you shouldn't be doing is to understand why you shouldn't be doing it. The channel gives insights into harmful car habits people pick up over time. A good example of this is putting your vehicle on neutral when coasting down a hill. You might think you're saving fuel, but the truth is you're doing your car more harm than good. If you put your car on neutral while coasting down a hill, you have less control of the vehicle. Your ability to speed up is unavailable as you're not in gear. No one wants to drive a car they can't control, especially on a deep hill. Another reason is that in some states, it is illegal to do so. Imagine getting in trouble with the law because you put your car on neutral while coasting down a hill. There are about 15 states that have this law in place. Another valuable tip by Engineering Explained is for people with cars that have automatic transmission to stop moving the car before switching from drive to reverse or vice versa. The reason is that you're using your brake to stop the vehicle rather than the transmission. The transmission of an automatic transmission car is designed to shift gears. The brake, on the other hand, is designed to stop the car. If you don't do this, you'll be putting a lot of strain on the transmission clamps of your car, and when they get spoiled due to bad usage, it's quite difficult and expensive to get them fixed. Manual transmission cars were not left out of the equation, however. You should not rest your hands on the gear shift in a manual transmission car, and there's good reason for that. When you're shifting the gear, you have a selector fork, and you're pushing that selector fork up against a rotation collar. You press that collar against the gear you want to use, and this simply means that you have a static object moving back and forth, rubbing against a sort of rotating component that's used to select the gear. When you shift gears, there's going to be a little bit of wear on the selector fork, but because the movement is for a short duration, it isn't that big of a deal. What happens when you rest your hand on the gear is that you cause friction between the selector fork and the collar. This auto blunder will cause damage to your car. It can even prematurely wear on the gear forks of your car. You should never use your clutch to hold yourself on a hill. It's a pretty obvious thing to not do, but a lot of people still feather the throttle and the clutch pedal to get that spot where your car doesn't roll down the hill. What you're doing is burning up the friction material on the clutch disc. So, your clutch is spinning at one speed and your engine, which is at the pressure plate sandwiching the clutch disc and the flywheel, is rotating at another speed. In doing so, you'll be wearing out your clutch and you don't want that. This tutorial on the combustion engine of the Porsche Cayman GT4 RS is particularly interesting and informative. The video opens up with him going for test drives. The revving sound of the engine could not be more satisfying. What makes this car special is that the engine of the 911 GT3 was taken out and then put inside the Cayman. It's a 4-liter flat-6 naturally aspirated revs to 9,000 RPM with 493 horsepower and a top speed of 196 miles per hour. He gives us detailed information on what the car is like from the engineering point of view and what it feels like to drive it on a proper road and not an F1 track. The 493 horsepower is about 10 horsepower less compared to the 911 GT3. Was that an intentional action, or was there a purpose for it? According to the video, what they did was turn the engine and the transmission 180 degrees, placing the engine in the middle rather than at the rear. As a result, you have a car with a different exhaust path. The exhaust had to be turned around and then routed up over the rear axles. This caused some additional pressure loss in the exhaust. The pressure loss is unavoidable because of the bend that was made within it, and so they made just a little bit less power for the car. The engine has individual throttle bodies and it is responsive in an extraordinary way. The amount of control over the engine with a throttle is one of the noticeable features of the Porsche Cayman GT4 RS. These features are what makes this car quite different from a lot of other modern cars that we have around. Before we continue, please comment I sub below for a chance to win our monthly shoutout giveaway. Not only is Engineering Explained a guardian angel to cars, but they're also to the environment as well. Jason gives insight on what they shouldn't be doing with their cars. The channel also tells its viewers what they should be putting in their cars. In fact, in one of his recent videos on the channel, he tells viewers the benefits of using gasoline with corn-based ethanol. According to the video, corn-based ethanol is a dumb idea to use for fuel, but it's good for your car. Of course, he gives his reasons. The premise for putting corn-based ethanol in fuel is that it makes the fuel renewable. This means that the carbon footprint of the fuel is much smaller than gasoline itself. It's simple logic. The gasoline is a refined oil that was pulled from underneath the ground. Burning it puts CO2 into the atmosphere, and we don't want that, so we devise a way around it. We take CO2 out of the air while growing corn. We harvest the corn, dry it in the mill, ferment it, and then it is turned into ethanol. The ethanol is then burned into your car. But the problem is that burning the ethanol burns CO2 into the atmosphere. According to research by Tyler Lark, University in Wisconsin-Madison, he states that the full life cycle carbon intensity of corn-based ethanol and gas is 24% greater than gasoline. And that is the dumb part of the idea. The good is that the presence of ethanol in your car gives you a higher octane rating, and that way your engine does not have a knock. It also allows you to use higher compression ratios as well. It also oxygenates fuel, and this lowers the carbon monoxide emission of a fuel. But the truth is, you don't need to create that ethanol from corn. In fact, ethanol out of corn will give more room for the admission of CO2 into the atmosphere through the emissions of the factory machine that'll be processing it. So, although it's good for your car, it's bad for the environment, man. Engineering Explained has been in the business of guarding our cars for more than 10 years, and with 3.19 million subscribers and a collage of more than 800 videos, there's no backing down. Engineering Explained has some amazing content, as does Sab Kyle 04.